In this video, we're going to introduce the main ideas that we're going to be talking about in this unit on momentum. Momentum is an interesting concept. It can be kind of hard to imagine, but we've studied motion, right? We can have an object that is in motion. Well, objects generally have mass, and if it's in motion, it's going to have some amount of velocity. Momentum is really a measurement of how much motion does an object have. Where we said mass was a measurement of an object's inertia, momentum is going to be a measurement of how much motion it actually has. So let's actually write an equation for that to help this be a little easier to understand. We represent momentum with a p, of all things, and it's measured by mass times velocity. Now, momentum is a vector along with velocity, and the direction that momentum is going to be in the same direction as the velocity. So if this block has momentum, its momentum is going to be in the same direction as its velocity. Now, that on its own might seem simplistic and like, why does that matter? But when we start to look at collisions, momentum is going to be a key factor because we have this thing called the conservation of energy, right? Energy is always conserved. It can't be created or destroyed, but it can change forms. But momentum also has a conservation law. We have the law of the conservation of momentum. Momentum is conserved. If I have a couple of blocks colliding, the total momentum of those two blocks together, the total momentum before the collision will be equal to the total momentum after the collision. It will be the same amount. No matter how these blocks might trade their velocities, they will have the exact same amount of momentum. So momentum actually becomes an extremely useful concept because we have collisions all the time. And not only do we have collisions, we have things like explosions. Momentum will allow us to investigate things like ballistics, things like recoil, things like explosions and car crashes. So if we have a car speeding down the road, I'm just going to draw a block for this. I'm not going to go too in depth. If I have a car speeding down the road, let's say it's going at a velocity of 60 meters per second, that'd be very fast. What are the two ways that it could stop? Well, it could either stop very hard or very soft. So it could either slam on the brakes and stop in a matter of inches, or it could steadily pump the brakes and take its time and slow down so steadily that you can't even feel it. What would be the difference in those two? Well, the difference between them is going to be the force that you feel and the amount of time it takes to stop. This one right here, this first one, the time it takes to stop is very small. So it's very small. Where this one, the time it takes is going to be very long. It's going to take a long time. And when it takes a longer time to stop, we're not going to experience as much force. And so if the time is large, the force is small. But when we stop in a very short amount of time, this very sudden stop, if you slam on the brakes, your force is going to be very large. You may have experienced this. If you ever had to slam on the brakes, you feel your body try to slam forward against your seatbelt. Well, this relationship is very much related to momentum. And that's going to be because if we ever have a change in momentum, if we have the change in momentum, this object goes from having a mass times 60 meters per second to having a mass and velocity being 0. That means we had a change in momentum. And a change in momentum is going to be equal to this thing called impulse. Impulse is going to be a force times a time. So force times time is impulse and is related to the change in momentum. If we want to change the momentum of an object, we need to apply a force for a certain amount of time. We can see this should make sense because momentum is made up of mass times velocity, so that's going to be kilogram meters per second. Forces are kilogram meters per second squared, and if I multiply it by time, it's a second, I lose that square, and I get kilogram meters per second. So my units line up nicely. So the impulse momentum theorem is just this. It's that mass times a change in velocity is going to be equal to force times a change in time. Stated more simply, my change in momentum will just be force times time, just like up here.